Welcome back to the video. I have a really fun project for you today that you could replicate in your high school or college lab. And if you want more information about how I do this, let me know in the comments below. But I have two powders here, one that I'm going to call a white powder and another that I'm going to call a brown powder. And with these powders, I've removed much of the identifying information. And the goal is to use a device like this called a portable infrared spectrophotometer to determine their composition and match it to a chemical library that I have stored locally on my computer. Also, if you want that data, let me know in the comments and I will find a way to share that with you. So the goal is to match the chemical fingerprint, and I'm going to demonstrate that in two different ways, one using machine learning and another one using correlation analysis. So I've taken this spoon and have crushed two different tablets, and I know the identity of those tablets should be in my chemical library. And all I have to do is calibrate this device and then measure how these different powders interact with the light. And that should give me a chemical signature that I can then use to match to my chemical library. To do that, I'm just going to remove this back sensor plate, turn the sensor on, calibrate it, and then record the composition of them. And just like that, we've recorded our data. So with some simple signal processing, I'm now going to demonstrate how these two new powders look when we compare them to our entire chemical library. If you look on the screen, we have now added a dotted line and our dashed line. Both of these samples in black are the unknown powders. The dashed line is the brown powder, and the dotted line up here is the white powder. So here visually, we can see it's maybe difficult to assign the identity. But what if we measure the correlation of these samples to the rest of the chemical library? If we do this with the brown powder, we see that it's highly correlated with the ibuprofen and acetaminophen sample crushed, and the acetaminophen crushed sample there at 95% correlated to both of these samples. If you look further down, the ibuprofen crushed is 90%, and then we go down into the mid and high 80% correlation. If we look at the white powder, we see that it's most correlated with the acetaminophen crushed sample at 88%. And then we have ibuprofen and acetaminophen crushed at 80%. And then we go much lower as we look at the rest of the samples and our chemical library. So correlation analysis would suggest that the brown powder is most likely going to be ibuprofen and acetaminophen. And then the white powder is likely going to be the acetaminophen crushed sample. But of course, we could take our chemical library and just build a machine learning model that we could then use to predict the identity of the unknown samples. And so let's do that as well. We're going to build a simple pipeline that will first z-scale the data using the standard scaler. We're also going to use PCA as a sample processing step in order to reduce the dimensionality of our NIR data. And finally, we're going to make our prediction step using a support vector classifier. And when we validate this model on our testing data, so this is after a train test split, we actually have really good performance from this model. Now, your instincts might suggest that this data is starting to overfit, but let me demonstrate something that helps us gain confidence in the performance of this model. Now, as I mentioned before, our model pipeline uses PCA as a pre-processing step. So I want to extract that layer of the pipeline and show you what that looks like. So this is the scores data from PC1 versus PC2 on the left and PC2 versus PC3 on the right. And what we can see here is that we're getting really nice clusters of all of the pharmaceuticals between these three principal components, where the orange, green, pink, and brown all cluster pretty far from each other. And then if we look at here, the red and blue separate in PC2 versus PC3. And even while we have some tightness here between these two classes of materials, they separate pretty convincingly when we look at PC2 versus 3. So with this pre-processing step, plus a support vector classifier, it's actually going to be really easy for the model to separate these classes based on the NIR chemical fingerprints. And so when we pass it the chemical fingerprints of our two unknown powders, the model predicts the white powder to be acetaminophen crushed, and the brown powder is likely going to be an ibuprofen acetamin mix. And I can confirm that is true. And so this fun experiment just demonstrates the power of NIR and how much we can do with Python. And even while our visual assessment of the chemical fingerprints could be somewhat noisy, with the right signal processing and dimension reduction techniques, we can very easily gain confidence in the identity of these powders. And this is the cool kind of experiment that we can also perform in any classroom setting So if you want to understand more about how we might adapt this for that, also let me know in the comments below, and I'll see you in the next video. Peace.